We're going to talk about what went wrong for Leo, what happened to him, what even is vibe coding. And I'm going to get this idea in your head, which is that you cannot build what you do not understand. Because I think that there's a big difference between vibe coding and a less sexy term of AI-assisted coding, which is that when we vibe code, we're kind of building something and then hoping it works without understanding what we've actually built. But when we use AI in an assisted manner and we understand what we're instructing it to do, then we're able to make sure that we build securely. And to be clear, you don't need to be able to code to do that. We're going to talk about two security concepts: what can a user see and what can a user do. If you can nail those two things, then you're covering like 80% of the bases of web app security. Of course, with everything I'm about to tell you, there are a lot of asterisks and edge cases, but it's the way of thinking about security and some kind of terms to take away and get to grips with that you might want to take forward, whether you're building on Bubble, building with Xano, building a vibe-coded app with Cursor or RuCode, all that sorts of things. About me, I am the founder of Not Quite Unicorns. It's a gold-tier Bubble agency, and I pen test some of the largest Bubble apps in the wild. Pen testing basically means testing it and trying to hack into it. And the reason I do that is because they prefer me to hack into it than a malicious user that wants to exploit it or leak data. I built NQU Secure, which is a security platform for Bubble. That's entirely free. If you want to audit your Bubble app because you don't know how secure it is, you can use that. BuildPrint's a bit different. It documents your entire Bubble app. But the reason I built that is because BuildPrint isn't built on Bubble. I built BuildPrint kind of as a challenge to see what AI-assisted coding looks like and what challenges people run into so that I can deliver a talk like this and kind of communicate the issues that I run into so that you can avoid hitting them yourself. So in summary, I build apps, I review them, and I try and break them. But what went wrong for Leo? First of all, he didn't restrict what users could see. His entire database was public, which allowed them to access things which they shouldn't have been able to do. He didn't restrict what the users could do. They were able to add anything to their database. They were able to modify records as they pleased. And then third, we should accept in a security model that there's a chance that there may be an exploit. We try and develop things as securely as we can, but there are always edge cases which we'll never anticipate. And it's really important that we assume that and we put mitigations in place so that if there is an exploit, the impacts of that are mitigated. So what is vibe coding? Hands up if you're familiar with vibe coding as a term. Hands up if you've actually tried vibe coding. Hands up if you've thought about trying vibe coding but never got around to it. Okay. So vibe coding is, roughly speaking, prompting an AI to build an app without actually looking at what it's written. Like you kind of build it and then you go, I think it works, and then you hit deploy and your app works. Platforms where you can do this, platforms like Lovable, Cursor, Replit, Windsurf, Bolt, Klein, RuCode, all different variants of the same concept. That's great for speed and accessibility because it means you can build anything super, super fast. And it also means that these things are accessible to you as a non-technical user. But an MVP is very different from being ready for launch. This idea that you cannot build what you don't understand is really important. I don't think that vibe coding has much of a future, but using AI to assist with your coding does. And by that, I mean you have to understand what you are instructing the AI to do and understand what the AI has built for you. That doesn't mean that you need to understand every single line of code at all. But roughly speaking, you need to know this piece of logic calls another piece of logic, or at this point in the app, we're checking who the user is so that we can verify what they're doing. That's the kind of high-level knowledge that you need of the app that you're building for it to work. And it's insufficient for it to just work. It also needs to be secure, because none of you are here because you're just building apps. You're also trying to build businesses. You have a duty of care for users' data. It's not cool to leak user data. You can quote me on that. But you also have legal requirements, things like GDPR and privacy policy. You're required to take reasonable measures to protect your user data. And if not, you're probably in breach of your own privacy policy. So it's really, really important to get it right. First security concept, your browser knows everything. Some of you that will be self-evident, but it's kind of not straightforward to think about how that might be applied in security for your web apps. When we load a website, we make a request to a web server, and that sends back a bunch of data that we then load in our browser. But what we see in the website isn't all that there is in the app. There's a lot behind the scenes which has been sent to us, which isn't displayed and is still able to be inspected or tampered with. So I'll give you an example of this. Suppose we have a web app, and on a certain page, we want it to basically show me all of my tasks. And that, when we want to do that, it makes a request to this endpoint on our server, which is called get tasks, and we pass my email, which is this, and we send it to the server. But this here happens on my browser, and before it gets to the server and before it ever leaves my computer, what if I swap out this email that we're requesting so that instead of getting the tasks for this user email, I instead swap it to another user? If we don't have any other security policies in place, the server will see this and it will return the data for that secret user. So to combat this, we need something called row-level security. It sounds complex, it's really not. But in any app, we have a database which has rows of data. And row-level security simply refers to, can I, as user X, access this row? So for example, here is a simple data table. I'm George, I want to only be able to access my data. I shouldn't be able to see Jack and Jill's at all. So to do that, we add a security rule. We might also have a more complex situation where tasks belong to a team, for example. They don't directly belong to me, but I belong to a team and tasks belong to a team. So if I'm on Team Green, I want to be able to see all of Team Green's tasks. We can express this, in Bubble at least, as a privacy rule. In words, I want to see all tasks where the current user's team, my team, is this task's team, where they're the same. We'd add an extra condition here to stop them, the case where it might be empty. But you get the principle of how we think about row-level security. And different applications different platforms have different ways of implementing this. So in Bubble, we call them privacy rules. In Xano, you use middleware or preconditions. There's all sorts of different terms, but most platforms will have some kind of row-level security feature. If you're using Airtable, you can restrict views to certain data, for example. So always add row-level security if your platform supports it. Bubble makes it pretty easy with privacy rules, and for most platforms, there are automated scanners to test this row-level security. The other thing that I would say, and this goes for all security things when you're building apps, is to add it early on, not just before launch. Because if you kind of take a security last approach and try and add it on later, what you'll find is that it creates all sorts of bugs. Because, for example, you might accidentally restrict an action which a user should be able to do, or you might fail to restrict an action that a user shouldn't be able to do. So by doing it as you go along, you're building a security-first approach, which makes sure that what you're building is secure and robust. Next concept, API keys. Pretty much everyone here has probably used an integration at some point. An API key is just a password. So if I want to talk to another service like OpenAI, I pass an API key, and that says who I am, so that OpenAI can check that I'm allowed to make that request and I can get whatever I want back from them. API keys need to be secret. You shouldn't be able to use my password, my API key, for OpenAI, because then you can start using all of my credits up and charging my account. And that means they need to be secret. And we need to understand this concept of client-side and server-side. So over here, we have a browser. And let's say we want to call OpenAI. This is what we'd look at as a bad configuration, where our browser, we trigger a button, and it contacts OpenAI directly. And it passes along that secret key, that API key, to OpenAI so that we can make the request. But the problem is, to do that, that means it has to be on the browser, which means that it's accessible to the user that's making the request. So that's not secret. When actually what we need to do is when we click that send message button, we need to send a message, but we need to send that to the server, send it to our app so that our app can add that secret key. And this is a safe space. This is between the server and OpenAI, so it's not accessible to the user. Anything that's in this gap between your app and the browser, the user could access. It sounds a little bit unintuitive, and other people will put it much more elegantly than I ever could. But most platforms, they'll have a way for you to securely place your API keys. But as a rule of thumb, well, as a hard rule, never place them in the browser directly. The other thing, and this is what Leo also didn't do earlier, is limiting your losses. We should accept that at some point there may be a security issue with the app. That's okay, but we need to put reasonable caps in place. So, for example, if my AI key gets leaked, It can't be used by someone to spin up thousands of dollars of requests on my account because I have a hard monthly limit of 500, for example. So that mitigates the potential consequences of any kind of leak. If you're unsure whether your key has been leaked, you need to rotate it, so you'll have the ability to revoke a key and generate a new one. You should build your app in a way where you only have to just swap your key and it just works. The other thing is that you can scope API keys. So I believe tools like Stripe, you can restrict it, so the API key can only use certain functions. So if you leak your Stripe API key, for example, which Stripe is a payment platform, it allows you to receive payments from your customers, process refunds. If you leak your Stripe admin API key, then that's really bad because a user can refund payments, they can basically do anything on your Stripe account, and a Stripe account's basically a bank account for a software as a service product. So it's really important to keep that secure. But if you restrict that API key so that it can only do things like create a new payment rather than refund payments unless it's necessary, then it means that if it's leaked, it's not the end of the world. So we thought a bit about what users can see in terms of data and API keys, but we also need to restrict what they can do, because just because I can see something, just because I can see a database row, doesn't mean that I should be able to interact with it. I might be able to see my team's tasks, for example, but I shouldn't be able to edit someone else's tasks. So for that, we need to understand the difference between authentication and authorization. Again, it sounds complex, and it is a bit boring, but it's necessary, and it's actually really simple. Authentication just refers to identifying who I am. So if you ask me my name, I'm authenticating myself because you then know who I am, and you can let me through the door. Authorization happens after I've been authenticated, and it checks, do I have permission to do something? So if I send a request to an app, first it's going to authenticate me so that it knows who I am, and then once it knows who I am, it can check whether I have permission to do the thing that I've just requested. And this is really important. I'll give you a real example. I was testing an app which has millions of users. It's one of the biggest bubble apps around. And they had an endpoint which was called send email. And all it would do is it would take the email to send to, the subject, and then the body of the email, and then it would send it as that platform's email. So I tested that, and it turns out it required authentication, but it didn't require authorization. So what that meant is that I could call that endpoint. All I had to do was identify myself as a user, but it didn't check that I had permission to do this. So I did what anyone would do, and I reported it to that platform. I did it by emailing them as themselves, which was interesting. It would be a missed opportunity if I didn't do that. But it's really important to get authorization right, because just proving who I am doesn't mean that I can do anything. Next thing is principle of least privilege. And again, this is kind of an idea. It's a concept to be thinking about rather than a specific technique that you should be implementing in your platform. We want to restrict actions so that users can do the bare minimum that's required for them. So for example, if you know that a logged out user in your app is never going to be able to do anything in the database, don't allow them to do that. If you know that a paying user only has access to certain features, only permit access to those through whatever logic you're implementing it. If you do not scope it tightly enough, then you're going to kind of screw yourself over because it's going to be hard to change later on. And it's a lot easier to permit access to things than it is to deny access to things. So rather than saying, if I am a logged out user, stop me from doing all of this, it's a lot easier to say, if I'm a logged in user, allow me to do this, and make additive permissions rather than kind of the opposite way of denying them permission to do something. And then there's this last one here. Input sanitization, which is that your users are curious and they will try to mess with your site, either by accident or intentionally. You can never trust what the user sends to your app. So for example, if we have an app here where users can donate, if we don't have a check on the server side which checks that the input is positive, that's probably going to cause a problem. Of course, it's self-evident that users should only be able to enter positive donation amounts, but if we don't actually check that in our app logic, then it's not going to be verified. Realistically, in this integration, it would probably just return an error, so it's a benign example. But users could, for example, a common one is being able to enter a 10,000 character long name, which would screw up the user interface for any user that sees them, for example. And it's that kind of thing that you can be thinking about in terms of how can we keep our database clean so that we always make sure that we check the values that are coming in. So I'll leave you with a little short checklist. This is completely non-exhaustive. This is like 30% of things that you could think about, but it's the ideas that I want you to take away rather than specific things like row-level security. Check not just who users are, but what they can do, and don't allow them to do any more than they should be able to do. The next thing is mitigating any consequences of security issues. I'll show you on the next slide, but security issues are generally the alignment of multiple little oversights rather than one big security issue. By mitigating the potential consequences of it, by doing things like placing limits on our API keys, we're mitigating the risk and the damage that could be associated with a security flaw in our app. And then finally, security is much easier to add at the start, not the end. We have a lot of clients who come to us and the app has no security, and we have the job of going through it and adding security basically, which is really hard because it causes a lot of bugs in these existing apps because it breaks things. Because you're restricting data access to users who previously had access by accident. So by doing it right the first time, it's a lot easier to kind of build your app in a way that is scalable and it isn't going to break when you think about security in the future. There's a few little search terms here. If you're familiar with any of these platforms and you want to learn more about what applies to you, you might find those useful. If you can't see, it's bubble privacy rules and workflow conditions. Xano, you've got preconditions and middleware. Airtable, you've got view filters and also edit permissions. And for Glide, you have row owners and roles. I'd recommend that you try breaking your own stuff. It can be fun sometimes. Your users will try and break it. If they don't, I will. So you might as well get there first and put yourselves in the shoes of an attacker. So give yourself a goal, like as an attacker, I want to be able to get access to this feature without a subscription. And you know your logic well. You know your app's logic and how it works, hopefully, because you haven't vibe coded it. And you're able to put yourselves in the shoes of an attacker and work out a path to be able to execute that, and you can test that yourself. So finally, most breaches are human error. According to Stanford, I trust them, and that's a good thing. It's not a bad thing because it means that 88% of breaches we can actually control just by putting in good practices. You might be wondering why there's cheese on my presentation. It's commonly used in aviation. It's a Swiss cheese model, but essentially each one of these red arrows is an exploit. It's a user being able to do something bad. But the holes are security vulnerabilities, and what we can see is that generally, if there's one security vulnerability, it's not going to be catastrophic for your entire app. But because we have multiple layers of security, we have to have a lot of stars align for there to be a security vulnerability in the app. And by making sure that we have lots of layers of security at various stages in your app's logic, you're minimizing the chance that one of these serious exploits gets through. That's all. Yeah, thank you very much.